Hey guys, today we're going to be talking about geometric proofs. Okay, what geometric proofs are kind of like algebraic proofs. In algebraic proofs, you're solving equation or whatever problem and then giving a justification on the right side for whatever makes you able to do that step. Okay, geometric proofs are a little bit different in that it will provide you steps on the left or the right, and you have to fill in the different justifications. So it's just a tiny bit different. You have to have a much better understanding of your different properties. Okay? So your objectives today want us to be able to write a two-column proof, and the other is to prove geometric theorems by using deductive reasoning that we learned earlier in this unit. Okay? So let's go ahead and get started. Up top it says, when writing a proof, it is important to justify each logical step with a reason. You can use symbols, abbreviations, but they must be clear enough so that anyone who reads your proof will understand them. And when you start with your proof, you'll always start with your hypothesis. Okay, and your hypothesis will lead you to different definitions, postulates, properties, and theorems that will help you prove your conclusion. Okay, so it's just a three-step process that will help you prove whatever theorem they're asking you to prove. Okay, so let's go ahead and get started with example 1. Okay, and it says write a justification for each step given that angle A and angle B are supplementary and measure angle A is 45 degrees. Okay, so on the left they've given you all the different steps for your proof. Okay, your first step is angle A and angle B are supplementary. Measure angle A equals 45 degrees. Well, if you'll notice, that information's all up here. That information is given to you. So whenever that happens, whenever information is given to you, all you have to do is write given in your justification box. Okay, anytime information is given to you, just write given in the justification box. Okay, the second one says measure angle A plus measure angle B equals 180 degrees. Okay, remember it said in the given that the angles are supplementary. So these two angles over here, A and B, are going to add up to 180 degrees. Okay, that's what we know. Okay, and we know that because we always know if two angles add up to 180 degrees that they're supplementary. So your reasoning for number 2 would just be that that's the definition of supplementary angles. Okay, that's the definition of supplementary angles. Okay, now our goal in this proof is really to prove what measure angle B is and prove that it's 135 degrees, which it shows down here. Okay, so we're going to go ahead and plug in some different values, and on number 3 it plugs in measure angle A, which was 45 degrees, because it gives you that information up top. Okay, so the reason that you can plug in 45 degrees, something you already knew, is that you can substitute it in. Okay, so that's your substitution property. Okay, so your substitution property allows you to plug in 45 into that equation that said measure angle A plus measure angle B equals 180 degrees. Okay, now what your goal is to solve for B. You're wanting to solve for this guy alone, so you want to get him all by yourself. So what you need to do is get this 45 over here, and if we wanted to do that, of course, we would just subtract 45 degrees on both sides, and we would get measure angle B equals 135 degrees. And the reason that you can do that is one of your 11 properties that was on your foldable the other day, and it was because of the subtraction property of equality. Okay, the subtraction property of equality on that one. Okay, so let's go ahead and try another one real quick. Alright. It says, write a justification for each step, given that B is the midpoint of AC and EF is congruent to AB. Okay, so your first step that it gives you says B is the midpoint of AC. Okay, that's up here in your justification. Okay, so we know that that is a given. Okay, so we know that that is a given because it is the midpoint of AC up in your given information. Okay, now it says that EF, or segment EF, is congruent to AB. Well, we already saw that up here as well. Okay, so far they've only given you information that was up top in your given information. So of course step 2 is also going to be given. Okay, your next step is that AB is congruent to BC. So what it's saying is that this segment is the same as this segment. And the only reason we know that is that when it says something is a midpoint, like this B, we know that a midpoint is located right in the middle, so it splits something in half. Okay, so it splits something in half, and that makes these two segments congruent. Okay, so we know that AB is congruent to BC because that's the definition. Sorry for my handwriting. Definition of a midpoint. Definition of a midpoint. Hey, and lastly, it says that EF is congruent to BC. Okay, since we know that EF is congruent to BC and AB is congruent to BC, we can go ahead and conclude that EF is congruent to BC because of your transitive property. Okay, your transitive property. Okay, what it's saying is if BC is congruent to EF and AB is congruent to BC, then you can go ahead and conclude that BC is congruent to EF. Okay, so hopefully this gives you a little bit of better idea of how to write your justifications for these. And on your test, you'll have a word bank, so it's not like you have to know these things 100%, but they will be there for you to help you just a small bit. Okay, let's go over a few different theorems. And what a theorem is just any statement that you can prove. And once you have proven a theorem, you can use it as many times as you need to, in later proofs. Okay, so a linear pair theorem is if two angles form a linear pair, then they are supplementary. Okay, a hypothesis would be that angle A and angle B form a linear pair, and your conclusion is that angle A and angle B are supplementary. Remember, a linear pair formed by angles is something that looks like this, where your two angles have a common vertex, they have a common side, and they form an opposite ray, where a ray starts at the same point and goes off in different directions. Okay, your congruent supplements theorem states that if two angles are supplementary to the same angle, then the two angles are congruent. So if angle 1 and angle 2 are supplementary, or add up to 180 degrees, then angle 2 and angle 3 are also supplementary. And what that means is that angle 1 and angle 3 are congruent. Okay, angle 1 and angle 3 are congruent. Alright, we're going to skip example number 2 and go to number 3 in the next. Okay, so it says fill in the blanks to complete a two-column proof of one case of the congruent supplements theorem. Okay, so we're going to take this really slow. It says for your givens, angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary. Okay, so on the right side of your proof it says that you're given information. So what you need to do is take these two pieces of information and plug them in your proof side of your your geometric proof. Okay, so number 2, it says measure angle 1 plus measure angle 2 equals 180 degrees. So this plus this is 180 degrees, and angle 2 plus angle 3 is 180 degrees. And we know that because that's the definition of supplementary angles. Two angles that up to 180 degrees are supplementary. Okay, then we learn that your next step is because substitution property, so we need to think of things that we can substitute in. And what you need to think of is that measure angle 1 plus measure angle 2 equals measure angle 2 plus measure angle 3. Okay, we know that because 1 and 2 add up to 180 degrees, and 2 and 3 also add up to 180 degrees. Okay, so you're substituting this in and learning to solve it. Okay, now you need to, basically you're wanting to solve and show that angle 1 is congruent to angle 3. Okay, so what you need to do is subtract out measure angle 2 on both sides. Those are going to cancel. And that, in effect, takes you from measure angle 1 to measure angle 3, which it shows right here. And the reason you can do that is your subtraction property. Okay, your subtraction property of equality. Subtraction property of equality. Okay, then your last step would just be that angle 1 congruent to angle 3. And that, of course, is your definition of congruent angles. Okay, so hopefully this has given you a good start on your different proofs, and hopefully we can work through these because it is challenging, but we'll keep practicing. Good job, guys.